regenerated gasoline and diesel production process flow. The waste oil, crude oil, distillation equipment for producing gasoline and diesel was developed by Henan Ruike in collaboration with multiple technical experts in the field, integrating advanced technologies. The core processes of the system include atmospheric and vacuum distillation systems and refined product oil systems, supporting facilities or storage and transportation systems, molten salt heating, condensate cooling, vacuum systems, pretreatment systems, and the DCS Control system. Key equipment include thin-film evaporators, fractionating columns, catalytic towers, high-temperature cracking furnaces, and refining units. Process flow description. Pretreatment system. Raw materials are pumped from the tank farm into the pretreatment system. Small amounts of additives are introduced based on the characteristics of the feedstock to remove mechanical impurities and adjust pH levels. Dehydration system. After pretreatment, the materials undergo heat exchange and are elevated in temperature before entering the dehydration system. Moisture is completely removed in this stage, while small amounts of light hydrocarbons are also extracted. The separated light components and water are routed to an oil-water separator. Light component removal system. The partially treated materials continue through heating exchange and further temperature elevation before entering the light component removal system. This process isolates volatile compounds to enhance final product quality in terms of color, odor, flash point, and oxidation stability, while also ensuring smooth system operation. Extracted naphtha components are cooled, condensed, and stored for subsequent refining once a sufficient quantity is accumulated. Thin-film evaporation system. The materials are again heated and transferred into the thin-film evaporation system. Which operates under high vacuum to separate heavy components. The thin-film evaporator shortens heating duration and minimizes the risk of coking caused by the thermal polymerization of heat-sensitive compounds. This extends operational uptime and enhances throughput. Fractionation and catalytic processing. The integration of the thin-film evaporator and the fractionating column improves the yield of intermediate products and extends the catalyst service life in the following steps. Heavy residues collected at the base of the evaporator are pumped into a high-temperature cracking furnace to further increase recovery. Meanwhile, lighter vapors from the top of the evaporator enter the fractionating column for separation. Top products are condensed, collected, and sent for refining, while set stream fractions are cooled, stored, reheated, and then fed into the catalytic cracking unit. Catalytic cracking process. In this phase, directional catalysts in the vapor phase break down long-chain hydrocarbons into C12 to C18 diesel-range molecules. The inclusion of a heavy component removal stage enhances the efficiency and completeness of cracking. leading to diesel products with higher and more consistent cetane numbers and increased yield. Final processing. Diesel fractions from the top of the fractionating column are cooled and collected before being transferred to the refining system. Heavier materials are recirculated to the thin film evaporator for secondary processing to optimize recovery. After blending and filtration in the refining system, the diesel is stored in finished product tanks. This system offers excellent adaptability to a variety of raw materials by fine-tuning operating parameters. It can ensure high product yields while meeting stringent specifications for flash point, cetane number, and volatility tailored to customer requirements.